Good afternoon, children. Welcome to 8th Standard Physical Science online class. This is 8th Standard Chemistry Unit 5 continuation. So, in this class, we are going to learn how to write a chemical reaction, how to write a balanced chemical reaction, and a more informative chemical reaction. Look at the tabular column given here. Here are some reactions are discussed and their skeleton equation. Skeleton equation is nothing but simply writing the symbol of the reactant and the products. Okay. First one, for example, first one, carbon dioxide dissolves in water to form carbonic acid, that is carbon dioxide CO2. We know the formula. Plus dissolves in water, isn't it? So it is H2O. Gives what is carbonic acid? H2CO3 is carbonic acid. This is a skeleton formula of the concerned reaction. Okay, the next one is ammonia dissolves in water to form ammonium hydroxide. Ammonia NH3. Water H2O dissolves form product is ammonium hydroxide NH4OH gives. And the third one, hydrogen reacts with chlorine to form hydrogen chloride. Hydrogen H2, chlorine Cl2 to form hydrogen chloride HCl. Next one is hydrogen reacts with oxygen to form water. H2, hydrogen, oxygen O2 to form H2O water. Under certain conditions, nitrogen reacts with the hydrogen to form ammonia. So, nitrogen N2, hydrogen H2 reacts to form NH3 is ammonia. So, these reactions, all these reactions are skeletal reaction. All these reactions are what reactions? Skeletal reaction. Now, we are going to learn how to balance a chemical equation. Is it clear? So, how to balance a chemical equation? Look at the following example. Carbon reacts with oxygen to form carbon dioxide. Is it a balanced equation? Yes, because the number of atoms of carbon and oxygen are equal on both the sides. In both the sides, we have one carbon atom, isn't it? And two oxygen, O2 is here. So, O2, two oxygen atom. So, the number of atoms of both the elements are equal on both LHS and RHS. So, it is a balanced equation. Look at the next one. The next one is CO2 plus H2O gives H2CO3. H2CO3. Is it a balanced one? Yes. Count the carbon atoms. Here in the left side we have one carbon. Right side also one carbon. Right? And what about hydrogen? Two hydrogens. Here also two hydrogens. How many oxygen? O2, 2. Here one. This is two oxygen and here one. So 2 plus 1, that is 3 oxygen. So this is also a balanced one. Okay. Now we are going to balance the following equation. So carbon reacts with oxygen to form carbon monoxide. Look at the number of carbon atoms here. It is what it is? It is 1 and 1. So it is equal. What about oxygen? 2 oxygen is here. Here only 1 oxygen. So it is not balanced. The equation is not balanced. How can we balance that? So we can balance this by following steps. So to balance the oxygen, place the coefficient 2 before the product. What is the product for us? CO is the product. So in order to balance the O2, so you can this is carbon monoxide. You can't change the formula. CO formula we can't change. So we can add the coefficient to the compound. So by adding the coefficient 2 is added there. 2 is added means now we will have how many carbons? 2 carbons on right hand side and only 1 carbon. Oxygen is balanced now. Now oxygen, 2 oxygen and here 2 into O, so 2 oxygen. Here 2 oxygen, so oxygen is balanced, but what about carbon? Carbon is not balanced. So we have to balance the carbon. How to balance the carbon? Yes, you can balance the carbon by placing a coefficient 2 before carbon on the left side. Okay, on the left side place the the coefficient 2 to carbon. Okay, so if you have added, now count the atoms. So there will be 2 carbon on the left side, also on the right side, right? And 2 oxygen on the left side and also 2 oxygen on the right side. So the number of atoms of carbon and oxygen are equal on both the left side, that is reactant side, and the right side, that is the product side. So now the equation is a balanced one. Okay, do you understood how to balance an equation? Yes, that sounds good. So the balanced equation is 2CO plus 2CO plus O2 gives 2CO is the balanced equation. Here is another example. H2 plus Cl2 gives HCl. So here we have how many hydrogen? 2 hydrogen, but here only 1. 2 chlorine, here also only 1. So what shall we do? We can add a coefficient 2 before HCl. Okay, add the coefficient 2 before HCl, so that it will become what? 2 HCl. Now count the number of atoms. 2 hydrogen on the left side and 2 hydrogen on the right side also. How many chlorine? 2 hydrogen on the left side and 2 into, this means coefficient means 2 into hydrogen, 2 into chlorine. Each atom you can multiply. So 2 hydrogen and 2 chlorine. So both the sides have 2 hydrogen and 2 chlorine. So the equation is a balanced one. Is it clear, children? Hope you have understood. Yes, the next example we are going to discuss is H2 plus O2 gives H2o. So here 2 hydrogen on the left side and 2 hydrogen on the right side. So it is balanced. What about oxygen? Oxygen 2 on the left and only 1 on the right. So how to balance this? In order to balance this, we can add the coefficient 2 to the right hand side. Coefficient 2 to the right hand side. So that the equation will become 2H2O. 2H2 plus O2 gives 2H2O. So now look at the number of atoms. 2 hydrogen on the left side. What about the right side? 2 into 2, how much? 2 2s are 4. 4 hydrogens on the right hand side. So it is not balanced. So what we have to do? We have to add the coefficient 2 to hydrogen. On the left side we are going to add the coefficient 2 to hydrogen. 2H2O plus O2 gives 2H2O. Now check out the number of atoms on both the sides. 2 2s are 4. 2 2s are 4, isn't it? 2 2s are how much? 4. 2 2s are 4 hydrogen. Here also 2 2s are 4 hydrogen. So hydrogen get balanced. What about oxygen? 2 oxygen. Here also 2 into oxygen, 2 oxygen. So the number of hydrogen and atoms are balanced now. Thus the equation is a balanced one now. Okay, children. This is how we can balance the equations. Do you understood? Now some other examples. Mg, magnesium plus oxygen gives magnesium oxide, that is Mg plus O2 gives MgO. So Mg, 1 Mg, so it is balanced, but oxygen O2, but here only 1. So we have to balance oxygen. How to balance? So to add the coefficient 2 to the right hand side. So now it will become 1 Mg and 2 Mg. But oxygen get balanced. What about the magnesium is imbalanced here. So in order to balance magnesium, add the coefficient 2 to Mg on the left side. Now look at the equation. 2 Mg on the left side and 2 Mg on the right side. 2 oxygen on the left side and 2 oxygen on the right side. So the equation is a balanced one. Okay, children. Now the next one. The next one is KClO3. Okay, now the next one is KClO3. The KClO3 is KClO3 reacts to form KCl plus O2. KCl is the number of KCl. How many K here? 1K. Here also 1K. Chlorine, 1 chlorine. Here also 1 chlorine. So both are balanced. What about oxygen? Oxygen is 3 and here only 2. So how can we balance? We have to balance the oxygen. So add the coefficient O on the right side. Okay, 3 on the right side. So now the equation will be KClO3 gives KCl plus 3O2. 3 2s are 6. It will become 6. So in order to balance the number, here also you add the coefficient 2. Okay, add the coefficient 2 to KCl on the left side. Now 2 KCl, 2K plus 2Cl. Okay, 2K plus 2Cl, 6 oxygen is present on the left side. What about the right side? Right side we have only 1K, 1Cl. So we have to balance KCl. So add the coefficient 2 to the right hand side to KCl. So now check out the number of atoms. 2K, 2 potassium, here also 2 potassium on the right side, 2 chlorine, here also 2 chlorine on the right side, 6 oxygen, here also 6 oxygen. So the equation is a balanced one. Okay, now the next one is N2 plus H2 forms Nh3. So here which is lagging there? N2, 2 hydrogen is here, but here only 1 nitrogen, 2 hydrogen is here, here 3, both are lagging. So first let us balance the nitrogen. So add the coefficient 2 to the product. So it will become N2, here also N2, but here H2, here 6 hydrogen. So balance the hydrogen. How can we balance? Add 3, the coefficient 3 to the reactant side, to hydrogen. So now the equation will be N2 plus 3 H2O gives 2 H2O. That is 2 nitrogen on the left side. Here also 2 nitrogen. 3 2s are 6. 6 hydrogen. 3 2s are 6. So the 6 hydrogen. Here also 2 3s are 6. So 6 hydrogen. So the equation is a balanced one. Okay. So look at the reaction. Na2CO3 plus HCl gives 2 NaCl plus H2O plus CO2. So which is imbalanced? 2 nitrogen, 2 sodium, 2 sodium, 1 chlorine, 1 carbon, 1 carbon, how many oxygen? 3 oxygen, 2 plus 1, 3 oxygen. It is balanced. Hydrogen, 1 hydrogen, but here it is 2 hydrogen and 1 chlorine, here 2 chlorine. So we have to balance hydrogen and chlorine. How to balance? So you can add the coefficient 2 to HCl. The coefficient 2 should be added to HCl. Now the equation will be 2 sodium, here also 2 sodium, 2 Na, 2 Na, 1 carbon, here also 1 carbon, 3 oxygen, here also 2 plus 1, 3 oxygen, 2 hydrogen, here also 2 hydrogen, 2 Cl, here also 2 Cl. So the equation is a balanced one. Okay, the number of atoms are equal on both the sides. So the equation is a balanced one. Is it clear? How to balance the equation? Do you understood, children? Hope you have understood. Now we will learn how to make chemical equations more informative. We can make this more informative by mentioning the conditions and catalyst. Conditions and a catalyst. The first one is conditions and catalyst must be mentioned. Remember what is a catalyst? Catalyst is a thing which take part in a reaction, which speed up the reaction, which either speed up the reaction but it will not take part in the reaction. That is called a catalyst. Okay. So mentioning the second one is mentioning the state of reactants and products. In which state? Solid state. S for solid state, yeah, L for liquid state, G for gaseous state, and for aqueous state we have to mention AQ. And also along with that, when these symbols are used, a downward arrow for precipitate. For the case of precipitate, downward arrow, and upward arrow for gases on the product side should be used. Instead of S, we can use for downward arrow mark. Okay, precipitate is always solid, so we can use the product will be either precipitate or gas, so you can use the downward arrow mark for precipitate and upward arrow mark for gas. Okay, the third condition is mentioning the name and color of a substance if needed. We have to mention the name and color of the substance if needed. So let us discuss some examples so that you can clearly understood So here are some examples. Hydrogen reacts with chlorine in the presence of light to form hydrogen chloride gas. H2 is a gas. Chlorine is also a gas in the presence of light, so that should be indicated above the arrow mark. To form 2HCl, 2HCl is also a gas. Okay, second one, when ignited, a mixture of hydrogen and oxygen in the volume ratio 2:1 explodes to form water vapor. 2H2, that is hydrogen is a gas, oxygen is also a gas, ignite. We are igniting, so we are mentioning that condition. That is what we have first learned, we have to mention the condition and the catalyst. That is mentioned here. And also that forms 2H2O. 2H2O again it's a vapor, so it is a gas. The third one, solid potassium chloride when heated at 200 to 300 degrees Celsius in the presence of manganese dioxide as a catalyst gives oxygen, leaving behind a residue of potassium chloride. So what you have to do here in this reaction, potassium chloride, that is KClO3, it is a solid. Okay, when we are heating them at 200 to 300 degrees Celsius, and also which should be present, catalyst should be present, manganese dioxide is MnO2, that is the catalyst that speed up the reaction, but it will not take part in the reaction, so it will form KCl, potassium chloride, and oxygen will be formed. So potassium chloride is a solid, that is mentioned here, and the oxygen, it's a gas, it is also mentioned here. So we have mentioned the catalyst and also the conditions, and also we have mentioned the states of the reactants and the products. Okay, is it clear? Yes. The next one is, for carbon dioxide turns lime water milky. Lime water, so calcium hydroxide, it is a aqueous, actually it is a aqueous solution, that is it dissolves in water, so it is a aqueous solution. So that is mentioned here. AQ is meant for this aqueous solution, and carbon dioxide, it's a gas, and it forms calcium carbonate, that a white color substance, that is this calcium carbonate, that is milky in nature, so the color is mentioned, and it is solid, and the water also formed, that is a liquid. Okay, then the last one, magnesium continues, a burning piece of magnesium continues to burn in a jar of carbon dioxide, forming a white smoky magnesium oxide with some black carbon particles. So magnesium, it is a solid, it reacts with oxygen, carbon dioxide, that is also a gas. When, which condition? It burns. Okay, it forms what? Magnesium oxide. What is the color of that magnesium oxide? It is white in color, and the carbon is formed. What is the color of the carbon? It is black in color. So the color of the products, the condition, the catalyst, the state of the substances, everything is mentioned in this reaction. So this is a, and also look at their number of atoms. Magnesium, 2 magnesium here, here also 2 magnesium, 1 carbon, here also 1 carbon, 2 oxygen, here also 2 oxygen. So the number of atoms of both the reactants and the products are balanced here. So this is a completely balanced informative reaction equation, chemical equation. Is it clear, children? Hope you have understood today's class very well, children. Complete your assignment and report in the group without fail, children. Also prepare well for your upcoming exams, children. Thank you. Meet you again.